Okay, we're going to be talking about arc length today. That is to say, if you have some sort of function, try to make it look different than all the other functions, y equals f of x, and you have some points a and b. Let's say you want to know what is the length of the line. What is the length of this curve from A to B? That is called the arc length. And that's what we want. Well, the trick is, like it always is to break it up into lots of little pieces. Break the interval AB up into little pieces, and each little piece will refer to a piece of arc length. And we will add all of those up, and we will get the total arc length. So the question is, what's going on here? Zoom! And the rough picture is that it is roughly a rectangle. And I know we've been doing this whole, it's roughly a rectangle. I know what we've been doing up until now is talking about this is b minus a over n, and that is right. But for now, I want to call it delta x, the change in x, however much the x changes from there to there. And this distance here is going to be the corresponding delta y, how much the y value changes relative to the x. Now, it's not actually a straight line, but if that's delta x and that's delta y, then this whole thing is the square root of delta x squared plus delta y squared. And if we add all of those up, we are going to get that the arc length, oh, can I skip it? Well, if I was doing the b minus a over n's, I would end up going through the Riemann sum. Basically what it is, I integrate from a to b of square root of delta x squared plus delta y squared. Except that traditionally what we do is, when you are dealing with an integral, we're talking about infinitely little bits. So really what it is from a to b of dx squared plus dy squared. And, well, it's too bad they don't both have a dx, because then you could take one out of the square root. Hey, we could, watch this. I'm going to call this integral from a to b of dx squared plus, I'm going to call this dy over dx. One step at a time. I'm going to call this dy squared times dx squared over dx squared, all the square root. And then of these, I can pull a dx out from a to b. I'll put it out front for now. Dx squared times 1 plus dy over dx. That whole thing is squared. And the square root of dx squared is dx. That goes at the end. The integral from a to b, square root of 1 plus dy dx squared dx. This, we split it in half. This thing is just dx because it's the square root of dx squared. And ta-da! In general, the arc length of y equals f of x from x equals a to x equals b will be the integral from a to b of the square root of 1 plus the derivative of f squared dx. In fact, dy dx, that is your derivative. I could have done this with b minus a over n's, but we're at the end, and this video is so much shorter than most of them. I don't think you're going to complain about it. Why don't I do a couple examples and call it a night?